Good to go? All right, can you just get my PowerPoint back up there? All right, good morning, everybody. Welcome to Wales Darby Webinar Wednesdays. My name is Rob Clemens. In the background, working on the cameras, we have Mr. Brett Clemens. Also in the background here to answer any questions that you may have, we have Jimmy Fry from our Long Island office. If you see on the right-hand side, you have a control panel.
Hey, hold on.
Are we not?
Hold on. You're live.
Oh, I'm live still. Oh, okay, I'm sorry. On the right-hand side of your screen, you have a control panel. Inside the control panel, there will be a question box where you will be able to ask us questions directly. I don't have my PowerPoint up there again.
Okay.
All right.
Hold on, guys.
So we're having a little bit of technical difficulties this morning getting the camera systems up and running. So just bear with us for a second. In the meantime, you can just, I guess, enjoy the look on my face.
I'm not showing the presentation for everybody else.
I don't see the presentation at all.
Sorry, guys.
Worst case scenario, if you just put it on the screen, I'll have to kind of, yeah, there we go. So it's up there now.
Nobody else is seeing that.
Okay, what are they actually seeing at the moment?
The intro screen.
Oh. Yeah, can we get it to at least show my face?
Sure.
At least, because I have the units here, I could just, go over what's on the PowerPoint, without having the actual visual of the PowerPoint. I just need the PowerPoint up on the screen so I can. Can we edit the first, 10 minutes of this?
It's not showing it. It's not showing the.
Okay, so James is saying that he sees us now.
But you don't see the presentation.
I see the presentation up on the screen now. So I don't think they're going to be able to see it, but that's not a big deal. I can, kind of discuss what's going on there, talk to them. We got the visual, we got me. I think that's good enough, right? So.
See that?
Anyways, so getting to the presentation here today, we are talking about the hybrid electric heat pump water heaters offering by A.O. Smith's been out a couple of years now. Very robust product, multitude of different applications, which we're going to go over. So basically, first thing I want to point out is if you take a look at this heater here, which is to my right, it's going to be to your left on your screen, but to my right, here is our hybrid heat pump water heater. This is the 50-gallon. We have actually three offerings for this product line. We have a 50-gallon, a 66-gallon, and an 80-gallon. But today we're looking right here at our 55. So if you take a look, first thing you're going to notice is there's two black covers on the front. Actually, you might not see the lower one. These are two 4,500-watt elements. So these heaters, basically, the bottom half is just like an electric water heater. All right, we do have that backup electric elements for redundancy. Also, if we reach a demand, let's say the tank temperature goes down to below 76 degrees, both of these heater elements are going to turn on, and they're going to help the top portion, which is the heat pump, to help get the tank back up to temperature. So a lot of the components are going to be the same. You're going to have a cold water inlet. You're going to have a hot water outlet. You're going to have one electrical connection point. So very simple as far as the wiring is concerned. We also have an ASME rated temperature and pressure relief valve. That's located right over here on the front. All right. Since we do have the hybrid heat pump on the top of the unit, this unit is going to be a side inlet and outlet as far as the water supply and cold water supply and hot water inlet outlet are concerned. They're going to be on the side of the tank. So up near the top, you're going to have your hot tube, which is going to be clearly labeled in red, and down at the bottom, it's going to be the cold water inlet, which is going to be clearly labeled blue. So very simple as far as that's concerned. Over here on the right-hand side of the unit, you can see 2 wires are sticking out. That's where we're going to make our wire connections, okay? There is a ground screw on the inside as well to attach a ground. It is recommended that you have some sort of disconnect switch somewhere near the unit so that you can, while servicing, be able to shut the unit down.
Hey, Rob.
All right.
Hey, Rob.
One last thing.
Sure. We're going to try one more thing to try to get this thing, get the PowerPoint up on the screen.
Rob, can you hear me? Rob?
I can hear you, Jimmy.
Yep.
Oh, okay, good,
I
because
was just going over the questions that were on there.
some people say they can't see the PowerPoint.
So yes, we apologize. We're trying to get the presentation and the camera up on the screen. We might not be able to get the presentation up there. We're trying to get that as far as the PowerPoint is concerned up on the screen. Just having some, I don't understand the technical aspect of it, but
Sorry about that, guys.
no worries. We're good. How do I see the water heater? So this is the water heater here. I don't know if we can maybe get a better shot of it. I can kind of go through, some of the things that we see here at least. That pretty much did so already. But in any sense, the unit works very much like an electric water heater, with the exception of now we are introducing this heat pump to the top of the system. Brett, if I can get my PowerPoint back up to the top, I think we're just going to have to go through it like that. Unfortunately, they won't have the visual of the PowerPoint.
I'm trying my best, buddy.
That's all right. Not your fault. All good. So.
You got that?
Yep, I got it now. So basically how the system operates, we have a air intake up at the top of the unit right here. Underneath, above that, there is a filter that we have attached to the unit. Because we're constantly pulling air across the coil, we want to make sure that we are protecting it. So this filter is going to go into the top. It's going to just slide into place, locks in very tight, so it's not going to fall out at any point in time. So you have that. On this side here, we have our outlet side, all right, which you can see inside the unit. There's our fan. So that's technically our compressor fan motor. We are pulling air in across the top and ejecting the air from the front of the unit. So in applications where this is installed, you're going to notice a difference in temperature. It's going to come out roughly, about 10 to 15 degrees cooler than the environment air. So you will notice a little bit of a difference there. Basically, because it's working like a heat pump. I think we got it all up there now.
I got it.
There it is.
Yes,
Sorry about that, guys.
yes.
All right,
You
perfect.
control your PowerPoint.
All right, now if we can, yep, no, I can't control the PowerPoint yet.
There you
Hey,
go.
Rob,
There it is.
Got
All
it.
right, perfect.
I got a question. What size?
Okay, so as you can see, what I was saying before, we do have this heat pump technology. That's going to be the top half of the unit. We do have an advanced electrical control, which is something that's going to be different as opposed to our standard ENT50 electric water heater. So we have a control that you can actually go through some options. I'll go through it more in depth in a little bit, but we have that interface control. All right, at the top of the system, there is that evaporator and compressor. All right, it is a closed loop circulation system. So from the compressor at the top of the unit, we're doing our compression. We're taking the air temperature, the hot air, and transferring it into the gas of the refrigerant, which then, if you could see on the screen, comes down into this coil that goes all the way around the bottom of the tank, and that is what is actually doing the heat exchange into the water. Then refrigerant comes back to the compressor to be compressed again.
Hey guys,
We do have a glass-lined tank, which is like a ceramic, a porcelain enamel glass, just like every one of our tanks. We have this liner on all of them to make sure that we are protecting the actual metal of the tank from anything that may be in the system, as far as hard water or maybe corrosive water if we're in a well system. We do have an anode rod with the system. On the 50-gallon, there is one. On the 66 and the 80, we give you a second anode rod for more protection on those because of the larger tank size. And also, if you run into a situation where you have maybe smelly water, so to speak, we can also get a electric anode in the system as well. We have one for that application. All right. So there you can see basically how the system works. The hot air comes in on one side.
I'd like to ask a question.
Sure. What's up?
Yeah, there's what size circuit breaker for the 55-gallon?
What size circuit breaker for the 55-gallon?
So all all of the systems are going to be 30 amp breaker, which I'll go over that and the wire size later in the presentation. All right. So you can see here up on the screen, you have the hot air in, you have your cold air out, you have your cold water in, your hot water out, and you have that spherical coil on the inside of the tank itself. All right. So some of the advantages of using a hybrid heat pump water heater. First, we don't have to worry about doing any gas or oil piping to the system. So depending on the application, if you are perhaps maybe taking out one of these old water heaters, whether it's oil or gas, we don't have to worry about reconnecting all of that. Secondly, no flue venting. All right. So we don't have to worry about, finding a place to, get our exhaust gases out from the system. On top of that, we're also eliminating any of the dangers that, we could come across by using combustible fuels. So, fires, for instance, we can help prevent, a unit from, having that kind of a failure, or, maybe carbon monoxide or something along those lines. So we're eliminating all of those. Not only that, but we're cutting down on the cost. So if you take a standard water heater, for instance, we can actually save up to 73% on utility costs, depending on where your location, what your temperatures of the ambient air coming into the units are. So, we'll go over a little bit of that as well. And then lastly, depending on what area you are in, we also have rebates and possibly even tax credits for installing the system. One of the things that have been occurring more over the last 5 years or so, we've kind of been trending towards this strategic electrification where I believe it's 185 cities nationwide have signed on to this to be 80% less reliant on combustion fuels for heating, air conditioning, even our vehicles. You see a lot of electrical vehicles out there nowadays. So along the same lines, we want to cut down on greenhouse gas usage by 80% by 2050. Okay, so being that is the case, we're seeing a lot more companies start to come out with these products, and on top of that, because the local governments are trying so hard to get these pieces of equipment installed, they're offering rebates and tax credits as well. So that's a bunch of different advantages we have of going with the heat pump water heater. So applications, as far as that's concerned, I mean, basically, we can pretty much install these units anywhere. The places where they're going to live the best, as you can see on the bottom of the screen, the warmer the environment, the better the efficiency is going to be on the equipment. So if you are installing this in a cool basement, it's probably not going to be as efficient as, let's say, maybe a large boiler room that has a bunch of boilers running and is producing a lot of heat, because we are actually taking that heat energy out of the air and transferring it into the water. All right, so we could do new construction, retrofit applications, single-family homes, multi-family homes. We've seen them in multitude of different facilities, courthouses. I've seen them in hospitals. Whole bunch of different applications. So one of the things I want to allude to is that in this application with these heaters, sometimes bigger is actually better. In most applications, you would think otherwise, because we don't want to short cycle the systems, constantly have them come on and come off. But being that there is a much slower recovery on the heat pump technology, by having a bigger system and keeping a larger supply, a larger supply in your tank, it could actually be helpful. So a couple of things there. So as you can see on the screen now, there's our model lineup. We also have the CHP 120, which is the commercial boiler system. Commercial hybrid heat pump water system. We're not really going to go over it too much. Just kind of wanted to, show you there in the lineup that it is available. Okay. So one of the things we want to make sure of, because as I said before, the heat pump system does take longer to recover than a standard system would. We want to make sure that we have enough hot water for the environment that we're installing it in. So as you can see there, the HPTU, we can have 33 minutes for a single shower length, 4.2 showers back to back. All right, so it's a pretty good supply there. Heading upwards towards the HPTU 66 gallon heater, we could get up to 46 minutes per shower. And the 80, we could get up to 55. So if you have someone like my wife, Mrs. Clemens, she likes to take nice long showers in the morning. So, she could probably eat up most of that 55 minutes if she really wanted to. Right, so we want to make sure that we are sizing the system to the environment, making sure that we have enough water supply to reach the peak demand of the system. All right, so some of the things that we want to know before we do the installation. First things first, we need 700 cubic feet of air within the environment that the heater is going to be installed in. So that would roughly be a room with an 8-foot ceiling would be roughly 10 by 8 would give us that 700 cubic feet of air. All right, if we don't have that, let's say we're installing in a closet, maybe we're doing a multi-family home or something along those lines. If that is the case, we don't have enough airflow for the system. Basically, what we want to do then is they make a duct kit that installs in the top of the unit. So the duct kit slides in where this filter is, and then you can attach ductwork from there and run it to the outside to bring in enough fresh air for the heater. Okay, so that's something that's going to be very important.
I have a question.
Basically, what happens if you install it in a closed system, we're going to treat the air in there. We're going to pull the hot air out of the environment, and then the unit producing the cold air is going to make that room very cool, and we're not going to be able to recover quick enough. We're going to turn into an electric water heater in that instance.
We have a question.
Okay.
Customer has a
there
CHP 120 model. How do we bring this unit?
120 model.
Okay.
How do we bring this unit to BAC net?
How do you bring it to BAC net?
To BACnet. So what I would prefer if we could save that question, if he could send that to me in an email. My email address is rclemens@walesdarby.com. Just send the email with that question, and I will reach out to you sometime, right after the presentation is over to go over the BACnet. All right.
One other question.
One question.
Yep.
Can we do recirc?
That's it.
Can we
Okay.
do
One more.
Can we do one recirc?
Can we do research?
Yes. So if you can see right here at the bottom of this slide, recirculation is not recommended for this type of heater. And basically, the reason why is because of, once again, the slow recovery of the system. All right. So with a recirc loop, we're kind of increasing that demand. So it's not really recommended. However, it is done in certain situations. So I wouldn't recommend doing it personally. All right. Another thing we want to make sure of is that the installation is installed in an environment where there's no harsh chemicals like bleach, chloride, fluoride, anything that could be considered a harsh acid that could affect all of the components in the system, from the nipples to even the coil, the evaporator coil on the top of the unit. So make sure that we are chemical free in those environments. Keep in mind the heat pump function works between 45 and 100 degrees. All right. What that means is basically at 45 degrees and 120 degrees, the unit is going to go into electric only mode. And the reason why it's going to do that is trying to protect the compressor itself from being overheated. All right. So between 45 and 120 degrees, the system will operate. That's ambient temperature, not tank water temperature. Okay. So keep that in mind. Next, recommended water pressure. We don't want to see any more than 50 pounds per 50 psi in the system. We do have protection, obviously, with the ASME temperature and pressure relief valve. All right. Next, always install the system upright in a vertical position and make sure it's on a level surface. Don't install it in like a sand basement or sand crawl space or whatever you may have. We want to make sure it's on a nice solid footing so there's no chance that we could have that system adjust or move over time. All right. Another thing, and for the same reason as recirculation, we don't want to use these systems for space heating. I know there's a lot of applications in multifamily buildings, especially where they're using the hydronic air handlers for heat, and they're using the water heaters to provide that heat for the environment. Not recommended for this application for the same reason. We just don't recover the water temperature fast enough to support that kind of application.
Couple more questions.
So,
Hold on.
Yep.
Go ahead.
How much time does it take to heat up the tank 50-degree input?
How long does it take to heat up the tank 50-degree input?
How long does it take how long does it take to heat at 50 degrees? Is that what the question was?
How much time does it take to heat up the tank from 50-degree input? From 50-degree
Heat it
input.
up from 50 degrees input.
So from 50-degree input, it's going to be both electric and heat pump. So it's going to go into its hybrid running cycle. Basically, each kilowatt of power is going to give you 3,400 BTUs, 3,412 BTUs. We have two 4,500 watt elements, so that's 24,000 BTUs an hour. I mean, just think of it in that application as much as a standard electric water heater would be able to produce. We don't start really seeing the advantages of the heat pump until the tank temperature is, kind of at its set point originally. Now it's only going to run in that heat pump mode. So from a cold start, it's going to take a couple of hours.
Okay. One other question.
And that also depends on, your incoming water temperature, your environment as well. If you have the heater installed in a warmer environment, it's going to heat up quicker.
One other question.
Yeah.
Can you install in a cold attic?
Can you install it in a cold attic?
I wouldn't recommend installing it in a cold attic unless you are, somehow able to bring warmer air across the coil to the system. If you are installing in an attic, you always want to make sure that everything is going to be insulated properly. But for the heat pump itself, in the summertime that would work great, but in the wintertime you're going to have a problem, with the system constantly being in electric mode because the temperature of the attic is going to be too low. And even in the summertime, you're probably going to get over 120 degrees, so it's probably going to be electric heat only in that application as well. So my recommendation is I wouldn't put it in an attic. All right, good to go. All right, so as you can see there, now we got a picture up on the screen of the heater itself. You can see where the two elements are located. You have your cold water blue inlet that's located down at the bottom of the unit. You have your hot water outlet located on the top, on the side. Both of them are going to be facing the side. We want to make sure that we're using unions and valves when we're doing an installation here. We want to be able to isolate the system for servicing and cleaning and whatnot. So valves and unions are definitely recommended as far as that's concerned. An expansion tank should be installed on the cold water side. Make sure it's going to be after that, after the valve on the cold water side. And the reason being is because we are heating water, that means we have thermal expansion happening, and we want to make sure that we are not over pressurizing the tank because of that. All right. On the water side, one of the things we want to make sure, this is very important to keep this chart in mind. This chart is located in every single installation manual that we have for any one of our water heaters. And basically what this is talking about is anytime we get the water temperature above 120 degrees Fahrenheit, we're running the risk of, burning our end user. All right, so if you take a look at the chart there, right around 120 degrees, it would take about a minute to cause a first degree burn. All right, when we elevate that temperature to 131 degrees, we're increasing that now from 1 minute to 5 seconds. All right, temperatures of 140 or above, we're talking about 2 seconds, 1 second respectively, and anything over 150 is going to cause an instant burn. So with that being said, we want to make sure that if we have a situation where maybe we have a commercial dishwasher in the system or something where we absolutely have to have the tank temperature at 140 degrees for bacterial reasons, that we have a mixing valve installed in the system. All right, so very important. Another reason why we would install a mixing valve in a system, this is something that's not really thought about so much. When you install a mixing valve in the system and elevate the temperature in the tank, what you're actually doing is you're actually increasing the capacity of that tank. All right, so let's say we have a 50-gallon tank and we set that temperature to 140 degrees, but we set our mixing valve to 120, 115 even maybe. What we're actually doing is we're mixing cold water in with the hot water that's coming out of the tank, so we're using less of the capacity within the tank. So we could actually get longer run times out of our water heater. So if you have that one job where the customer says, I'm sorry, but the unit that you installed is just not keeping up with my demand, this is a simple fix to that. You can install a mixing valve in the system, increase the capacity of the tank without having to actually replace the tank with a larger one. All right.
Question.
Yes.
Can we run water heated solar before the heater?
Can we run water heater solar before the heater?
Yes.
Solar? Yeah, so absolutely 100%. That's one of the things that we talk about a lot is because we're switching over to electric, we are now using electricity supplied by the home. So if you are actually getting your electricity supply from your solar panels, which most of the time are more than enough than you need for your home environment, yeah, absolutely, we could run this tank off of the solar power in your house, and you now virtually have hot water for free, or very little cost depending on your application. So Takeo makes a couple of nice mixing valves. We have the 5120 and the 5000 series mixing valves. On the screen there, you can kind of see a basic diagram of how that could look. Each one of these mixing valves does come with a flow check, so the flow check obviously is going to go on the down towards the cold water side. But you could see here, all right, there we go, down there. I was looking at the wrong screen. So here's your hot water supply out, here's your cold water supply in, and we're mixing right in this area here. So hot water comes out 140 degrees, mixes with cold to deliver 120 degrees out to the home. Basically just like that. You're just putting kind of like it's like a T in between the hot water and the cold water supply. Okay? So pretty simple as far as that's concerned. The 5120 series mixing valve, we have those available in, that should be sweat, not sweet. In sweat, NPT, PEX, CPVC, maximum flow through that valve is going to be 14 gallons per minute, and temperature ranges between 85 and 120 degrees, with sizes of 1/2 inch, 3/4, and 1 inch. Then looking over at our 5000 series mixing valve, we have we have also sweat, NPT, PEX, CPVC with up to 20 gallons per minute. We can operate outlet temperatures up to 175 degrees and also have 1/2 inch, 3/4, and 1 inch on the sizes. All right. So as far as the electrical connections are concerned, 30 amp breaker is required with the system. So what that means as far as the wire sizing is concerned, for 30 amps, we need a 10 wire supply to the system. One thing we want to make sure is that this is a home run. There's nothing else tied into this, into the same circuit with the water heater. And basically that's because we don't want to be, drawing when we're trying to run our compressor. So dedicated line, home run, try not to do any splices in between. Make the run as short as you possibly can. And the installation of that wire is very simple. Again, remembering that we want to make sure that there is a disconnect switch or on-off switch somewhere near the unit. So you can see right here, we have our black and our red wires out of the back of the tank, or side of the tank, I should say. That's where we're going to make our connection. There's also a ground screw behind this plate. So wire runs in, ties in right there. 3/4 Romex connector, pop it in, tighten it up. Nice and easy. It really doesn't get, much more simple than that. So,
2 questions.
all right, so you have that. Proper sized wire nut and connectors as well. I think we got a question. Two questions.
If the coils go out, can the heater still be used strictly for electric heat? Electric.
If the coils go out, say it again.
Can the heater still be used as strictly electric heater?
Can the heater still be used strictly as electric heater?
Yes, absolutely. So as I said, as soon as the tank temperature drops below 76 degrees, it's going to fire automatically for heat. However, in the event that the heat pump is not working, there will be an error code that comes up on the screen, and when that error code pops up, this will automatically switch to electric mode. All right, so we do have 4 modes of operation, which I'm going to go over when we talk about the controls. All right, so yes, if the compressor should fail, or that circuit, for instance, is just not operating properly, maybe there's a blockage in the lines or something, this tank will always switch itself over to electric because it's going to want to supply the demand.
Okay.
And the next one?
One other question, is that 208 volt a 30 amp?
Jimmy's getting bombarded with questions over there, huh?
That 208 at 30 volt.
Yes, that's a 208, right? 208 2-pole breaker, 208 230. Was that the question? Yep. Okay.
Yep.
All right. So 208 230, 30 amp breaker, 10 gauge wire for the supply. Make sure that the grounds are clean. All right. We want to make sure we're getting good contact on the ground. If we don't, it could actually cause one of our elements to burn out. Okay. I've seen that happen often on, electric type heaters. And another thing, when we're doing the installation, before we apply power to the system, we must make sure that the system has been filled with water. It does have dry fire protection, but still we want to make sure that there's water in the system just in case. All right. You look like you might have another question over there. Are you good? Okay. All right. We're good. So drains and temperature and pressure relief valve. So towards the back of the unit here, let's spin this guy around real quick. All right. As you can see here, we have a 6-foot drain hose with a plastic fitting that goes directly into the side of the unit, threads right in. All right, I'm not going to take it all the way off. This can go down into a condensate pump. There is actually a wire behind this plate here. You're not going to be able to see it here, but there's a little hole here. There's a wire in there. So if you're installing a drain pump in the system, and let's say that drain malfunctions, there's a wire in there that we're going to cut and splice that 2-wire to, and that will actually shut the compressor off in that application. So we run into a situation where the drain pump's not working. This will shut down the heat pump portion of the system. That error code will pop up on the screen, and the unit will automatically go into electric mode to continue to supply hot water to the building. All right, so you have that. This should have its own dedicated drain. We don't want to tee it into other drains in the system. For instance, the temperature and pressure relief valve, that should be going into its own separate drain. And also, if you are installing the unit in a drain pan, you would want to make sure that that drain pan also has its own dedicated drain. So you could have as many as 3 PVC pipes coming off of the system and going off to a drain somewhere in the system. We don't want to tee those together, all right? So there is a secondary drain as well. In case the primary drain gets clogged up, you can connect a 1/2-inch hose to the smaller port over here, and that will be a backup for that, all right? So pretty simple as far as that's concerned. The fresh air ducting kit, as I said before, installs on the top of the unit. We need to have that 700 cubic feet of air. We want to use as little ducting as possible, all right? So minimize it as much as we can if we are trying to get fresh air into the room. We have 50-foot max if we're not including a booster fan kit with the system. And if we are including a booster fan kit with the system, we could go up to 100-foot max on that. All right. So pretty easy as far as that's concerned as well. Getting down to the controls, another relatively simple aspect, very easy user interface as far as this is concerned. So there's my screen there. I put it up on the screen here so you guys can kind of see it a little bit better. So you can see we have 4 modes of operation. We have efficiency, hybrid, electric, and vacation mode. Efficiency means we are going to run only in heat pump. All right. If we are going to do a hybrid, which is what I recommend, because the efficiency mode really would probably be better fit for, you know, homes that are down south, for instance, like Florida, Texas, Arizona, places like that where it's a lot warmer out. The hybrid will allow us to run both in heating and heat pump mode. I'm sorry, electric and heat pump mode. However, the priority will be on hybrid, and the heat will kick on if it needs to. Then we have the electric only mode. That's basically where we're bypassing the heat pump altogether. So in that, like that question we had before, if we switch this, if we have an issue with that compressor and it goes into electric only mode, we also have the ability to kind of set that as it is. So as opposed to waiting for the tank temperature to drop down to 76 degrees before that electric heat kit kicks on, we could put it into electric mode and just run it electric constantly. Then we also have a vacation mode, which is you can't get to it by hitting the mode button. What we actually have to do is we have to hold down the up arrow for a few seconds until the vacation mode light is lit. Once the light is lit, we have the ability, if you take a look on the control, it says days, so Fahrenheit, Celsius, and then days. That will allow us to actually set the water heater. Let's say we're on vacation for 7 days and we'll be back in 7 days. You set that for 6 days, so the entire 6 days that you're away, that heater will maintain a low temperature in the tank, just to make sure that no bacteria can form in the system, and you know, we don't have any freezing going on within the system. And then on the 7th day, the unit kicks back on, and by the time you get home from your vacation, you should have a full tank of hot water. So a nice little design feature there. And then to scroll through Fahrenheit and Celsius, the only thing we have to do is hold down that temperature down button. Question?
Is the condensate water neutralized?
Is the condensate water neutralized?
Oh yes, I'm sorry. The condensate that is produced by this system does not need to be neutralized. Okay, it's not a system that is producing any kind of acidic gases. So yeah, so you're fine as far as that's concerned. You could run it straight into the drain.
What is the warranty
right.
on the heat pump section?
So, yep.
One question. What's the warranty on the heat pump section?
You know what? I'm not 100% sure off the top of my head. I believe 6 years.
I think so.
I believe it's 6 years. Not 100% positive. The last slide is going to contain my email address. So just send me that question in an email, and I'll get a response to you as soon as this class is over. All right. But I think a lot of our heaters on the residential side are at that 6 years. So it's either 6 or 10. All right. So anyways, one of the other problems that we see out there in the field is issues with flooding. Okay. Your standard water heater could last anywhere from 10 to 20-ish years. At some point in time, it's going to fail. All right. unless you're, overly cautious and you want to change the heater after 10 years, just because you don't want to have to deal with the hassle. There are people out there that'll do that, absolutely. However, if you are the kind of person that, I'm not going to change it until I have to, wait till it breaks before I worry about it. That's probably most everybody out there, right? Nobody has, especially nowadays, nobody really has the extra money to continuously throw at appliances throughout the home. You kind of want to buy them, only when you need to, right? So with that being said, one of the things that we want to try to do is provide solutions to our end users. And one of the things, especially when we're talking about multifamily homes that have multi-stories, a heater that fails, let's say, on the 10th floor and just continually drips, gravity is going to take that water to the lowest point, okay, until it can't go down anymore, which is, thousands of miles below the Earth's surface. It can continue to drop, right? But what we want to do is try to prevent costly repairs from this happening, all right? So the product that Taco came out with is called the leak breaker, and this will install right into the cold water side of the system. So over here, I'm just going to slide this guy out of my way for a second so I can bring this into view here. I am attached to the wall though. All right, we should be able to see that now. Okay, cool. All right, so the leak breaker itself, when I did my remote, you can see right here, we have it installed in the cold water inlet side. Actually, can they see that? Yes, okay, just making sure. So here's our leak breaker valve body here, cold water inlet side. Inside the tank, we have a sensor. Okay, so here's our sensor. It's kind of sitting here in the bottom of our drain pan, just hanging out, waiting to see if there's any kind of water in the system. And then we also have our control box right here. All right, which you can see right now is on. It's currently operating properly. It does have a function built in where it will be exercised. So one of the first versions that we had as far as the leak breaker was concerned, it just kind of went on the system, sat there, waited, and then when it saw when it saw water, it would close the valve. But unfortunately, we have a issue with limescale buildup here in New Jersey. So what was happening was the steel ball valve on the inside of this unit was getting limescale buildup within it. So Taco came up with the function in the control that when the system is in normal operation, every so often, maybe once a week or so, that this will automatically control that valve to open and close. So we no longer have to worry about building up of limescale that affects how the ball valve operates. All right, so it's also a very simple installation. This box will mount to your heater. In this case, we have just Velcro holding it on. So I just pop that off, nice and easy. Okay. Let's say we have an issue with the valve body, much like the zone sentries that Taco offers. There's a little lever that if you push in, it disengages the valve body. All right, so now I have this off. If I need to replace this, I don't have to go in and replace the whole valve. So this just pops off. All right, nice and easy. So unless there's a problem with the valve itself, we don't even have to touch that side. Slide that back in. So I'm going to try to be quiet as I do this. I have a wet rag right here. Here's my sensor, and I'm just going to touch it like this. All right, so it senses water. Now you hear the audible alarm. All right, that alarm is going to sound until it gets reset. And it will also close this valve completely. So when that alarm set, this valve closed. What happens in this case now, whatever is in the tank, we really can't do anything about. But, you know, a 50-gallon tank as opposed to all the water in the system, I'd much rather take my chances with that 50 gallons as far as the damage is concerned.
You
All
guys
right,
can't
so now I'm going to dry this off.
slide.
Excuse me.
The guys can't
I'm going to
hear
go
it.
over here.
Slide.
Oh, wait, hold on. Say it again, Jimmy.
Can't see, somebody's saying they can't see the slide, they can't see what you're doing, and they can't hear it.
Okay. We can hear it. Jimmy, you can see it, yes? Everybody else can see?
I can only see
Good.
a few things.
We good, Brett?
I mean, I'm seeing the whole slide. Hold on 2
Okay.
seconds.
Okay.
Okay. So all I did to shut the alarm off was hit the open button. As long as we're not still sensing water at that switch, it should open right back up. We now have the ability to go through the system, make sure we know where the leak came from. If we can fix it, great. If it has to be a replacement on the water heater, you know, at least we didn't cause damage to the rest of the building because of our water supply. So there we go. Wasn't marking there. So another cool feature about this is the ability to tag multiple sensors in a chain. All right, so here's my sensor here. As you can see, A, B both have this top portion kind of broken off. That tab just kind of snaps off, and C has that portion still connected. So basically, what that is, that top piece is the end of the switch. All right. So if we take that off, we now are able to daisy chain up to 10 of these sensors. No more than, I believe, 200 feet of wire also. Throughout the home. So basically now this could become almost like a flood detection system for the entire home. All right. Taco does offer a flood breaker as well. Different kind of setup, but for the water heater itself, this is a unit that we have. So one other quick thing I want to show you as far as the wiring is concerned, we have these clips that come right in, clip, so we can actually wire our wires in before clipping our wires into place. Makes it nice and easy for the installation, and we're just 1, 2 clicks, everything's connected. Slap this into place. Another thing about the control is it does have a battery backup. I recommend this stays as a battery backup. However, if you don't have electric supply to, 110 volt supply to the system, you can run this off a battery. However, the battery life is only going to be a few months. So do be advised of that. All right. So there you see it, 10-foot max in series, 200-foot the wire distance is the most we can go as far as that's concerned. All right, so lastly, another thing I wanted to talk about is water quality. So New York, New Jersey, we have some of the harshest water conditions in North America. All right. More than 85% of homes in this country have hard water in some way, shape, or form. We tend to be in the middle of the road. However, there's areas such as I did a job in Pennington, New Jersey, where the grains per gallon were like 15 and a half, so it would even be off of this scale. When we're dealing with well conditions, for instance, we can end up having really hard and harsh water conditions. So we want to be aware of that and kind of put in preventative measures in place beforehand if we know it's going to be an issue. You guys should be familiar with your areas around. Know where the hard water conditions are. If you think it might be a concern, even just for quick reference, you can go to different townships and go to their website, and you can see what their water quality shows. So you know beforehand when you're going into a home, say Mr. and Mrs. Smith are looking for a new water heater, say, I pulled this report before I came to your house because I just wanted to see what your water conditions are, and this is what I found. And then they might come to you and say, I've been noticing that some of my fixtures get clogged up with this substance, this hard calcite substance. All right. I pulled a couple of pictures off the internet, which, just some basic things that we could see out in the field. So shower heads, if you have a shower head that looks like this, everything's all clogged up with this calcite, which is, basically as hard as bone when it solidifies. That's what that would look like. When you think about the heat exchangers inside like a tankless water heater or something along those lines, this is what you could end up seeing in that application. Remember, the heat transfer is through those pipes. So you have water running through those pipes and flame all around it. And that unit, by design, is based off of flow. And if we are not giving enough heat into the water, the unit has no other choice but to deliver that water temperature. So it's going to modulate up to a higher speed. So we're actually applying more heat to that heat exchanger and still not getting that proper heat transfer. So over the course of time, eventually what happens is by expanding and contracting these pipes because of high heat, we're causing those heaters to foul out. And then if you take one of those exchangers rather, and cut it in half like we've done a few times over here, a lot of times that second picture there on the top is what you're going to see. All right, inside of piping, this is what it looks like when it's completely clogged up a pipe. Our heater elements, all right, like our heat pump water heater has. A lot of times, that's what happens when we have limescale buildup. The same thing. We are not transferring enough energy. That element stays hot for too long, eventually just fouls out. All right, we see it all the time. So something like that, hard water conditions. Over here on the bottom left, that could be some sort of galvanic corrosion, right? Two dissimilar metals by each other, although it does look like there is a dielectric union there. However, even by using a dielectric, if we have harsh water conditions, the elements within the water that cause that hard water condition actually expedite the process of galvanic corrosion. So you can see the same thing in the water heater right next to it. Oops, wrong button. Right down here. So this is where we're rotting right at where the element screws into the unit. And then lastly, an issue that we run into from time to time, temperature and pressure relief valves don't function properly because the calcite buildup inside doesn't allow that spring to open once we overpressurize the system, and that could cause a dangerous outcome. So water quality is a big issue here in the Northeast. We are aware of it. A.O. Smith is definitely aware of it. So they came up with a solution. They actually bought a couple of water companies, and now they're able to push these water quality products out. For instance, here is the AOW S500 water softener and the S400 water softener. different applications for different homes, depending on what you have. 1 to 2.5 bathrooms, that S400 is going to do it for you. 50,000 grain capacity for the AOW S500, perfect for homes with 3 to 5 bathrooms. So most applications, we're going to be looking at that S400 system. All right. That is a salt system, so we do have to change the media salt every so often. Just every so often, check on it, make sure that you have you still have salt within the system. Can hold up to 200 pounds of salt. Location is definitely going to matter. We don't want to install these outdoors because they do store water. There's no heating elements involved with it, so we want to make sure that we don't freeze the system. All right. Has a maximum flow rate of 7.5 GPM, as you can see. Operating pressures between 20 and 120 psi. Temperatures, anywhere from 40 to 120 degrees. So once again, attics, outdoors, unconditioned areas, not really recommended for this product. All right. Then we have our 50,000 grain capacity. 3 to 5 bathrooms. Up to 7 GPM. It's got the same salt storage capacity. Just the larger size for larger homes. So we also have, maybe if you're interested, not something that that I'm talking about on the presentation here, but we also have point of use water treatments or water filtration systems. We have ones that are very simple, inline, plug and play type deal, and then we also have ones that you have to actually add an extra faucet for, like the reverse osmosis system. So if you're a Scotch or a whiskey connoisseur and you love your drinks on the rocks and you want crystal clear ice cubes to go in your drink, get a reverse osmosis system installed at your bar. The system can only produce up to, I believe it's 6 gallons a day, if I remember correctly. So it's very slow recovering. So keep that in mind. But we have that as well. So reason why we want to do this, we want to protect our homes, right? Lime scale buildup can damage pretty much everything in the home that touches water. From sinks to tubs to toilets, you get that buildup around the inside of the toilet as well for hard water conditions. You're changing fixtures all the time. Multifamily buildings, something like this is huge. You get yourself a commercial system because after only a few years, you're going to have to start replacing some of these fixtures, whether it's bathroom sinks, kitchen sinks, shower heads. All of them. None of them are going to be immune to lime scale buildup. So anytime you have a metal touching this water, anytime you're heating the water, because that's when the elements within the water kind of activate and fall out of the water. That's where we see most of it. All right, and also saving money on soap and detergent. So. That job site that I was talking about in Pennington, New Jersey, one of the things that happened when I first pulled up to the site, I was sitting there talking to the contractor, and one of the residents of this multifamily building came up to me and said, "Hey, are you here to fix the soap problem?" And what they meant by the soap problem is when you have really harsh water conditions, and you take your normal hand soap, put it in your hands and try to lather it up, it basically doesn't lather. You have to use more, right? You have to keep putting more soap on you because you feel like you're not getting enough soap to make yourself actually clean. That is an example of what happens when you have really hard water in your home. So if you see yourself dealing with that, that's a good idea to start looking into some water treatment products, and we have them available. So if you would like to know more, you can visit us at walesdarby.com. Click on the training link. We have a whole bunch of videos. John Resso did a great job as far as the water conditioning products are concerned. You can check that out. Good knowledge there. He goes over specifically what these products do. Definitely a great thing. We do have another webinar coming up next week. That is the low temperature hydronics with today's technology. So John Resso and Jim DePalma, I think, are doing that one, if I remember correctly. But yeah, we have that going on next week, next Wednesday, same time, same place. And any questions?
I hear it.
Can't hear him anymore.
I'm just going to go through here. Looks like we had a lot here. All right. Yeah, I'm just going to go through these real quick.
Jim, did you say you can't hear it?
Well, now I can hear him. We done? Are we done?
Rob,
Yep.
they just want to know if you're checking through the rest of the questions. You all good?
Yeah. Yeah, I was just looking to see if we had any questions there. So for the two gentlemen that had questions that I didn't answer online, please take down my email address. Shoot me an email. I'll get that answer over to you by the end of today. For everyone else, I thank you for coming out. We truly appreciate your time, and we look forward to bringing you our next presentation. So thank you, and enjoy the rest of your day.
Okay, I'll call you guys in a little bit.
Okay. Can't get control.
Are we still live?
It won't let me.
Thankfully, I didn't pick my nose or anything, right?
No, sir. I can't get control of the.
Would it be okay if I end the webinar from my end?
Yes, sir.
Okay. All right, so let's do this. End webinar for all.